This is something that probably most of you will look at this and say, this is quite easy on the paper, but when it comes to reality, this is where it becomes really difficult. And we're going to discuss some of those aspects today. Now, just in terms of logistics, we're going to have a couple of breaks. First one around 10:30 or so. We'll go with the flow and see when it fits, and another one around maybe 11:45. All right. Now, my intention today is to take you through the following things. First, we're going to take a step back and look at different methodologies, starting from waterfall, looking at how is that different from Agile. There are different ways of doing Agile as well. We're going to discuss those. Some of the challenges, and I'm going to speak, and I'm going to give you a couple of examples taken from the real world. Examples I've been myself, I've faced myself in the past, but I'm going to share my experiences with those. And then looking to aspects of how to transform, both from looking at the cultural aspects, the challenges of that, challenges in terms of managing scope, budget, timelines, because these are different when it comes to Agile. I'm going to also show you some of the tools, for example, metrics. How to measure, for example, when you're coming from traditional waterfall methodologies, you have your metrics going into Agile, what is the difference? Organization change management, we're going to briefly address that, in the sense, what does it mean for the organization as a whole? And how can you make sure that you can adapt to that change and implement it successfully? And last and not least, what happens when you scale up Agile? Now, these are not going to be covered in that chronological order, but this just give you a summary of the outline of what I'm going to present. Now, just a checklist here. We should all have received this booklet here. It contains the slides that I'm going to cover today. And at the end, and you should also have some exercises. Now the exercises are quite extensive. We might not go through all the details of the exercises, so they're there for you when you go back home. You can maybe have a second look and fill in the details. So don't be worried if you not go, for example, to get the chance to do all the exercises, all the details of the exercises. Okay. Some of the stuff we also take as discussions, working groups, or on the whiteboard. Now, one thing I want to make sure before we start. First exercise for today. I want you all to stand up. All right. Now, I want to do two things. Make it three things. Make it too complicated. Yeah. First of all, say hello to your fellow tester that's sitting next to you, both on Rex and the left side. And if you're from in the back, explain your name, where you're coming from, and your expectation for the day. Okay? And I'll do this as well. So please get started. I just want to get us introduced here. My name is John Paul.
Expectation to learn about Agile. So how about anything about Agile? So I think that's a requirement. I think people to be Agile.
Okay. End of exercise. All right.
Is that for the pencil? So I want to know.
No, please, yeah.
Stop it now. We can continue the break. Okay, now please sit down. Please sit down. Okay. Now we're all friends. We can get relaxed. Now the point is also, if you take a look at the room, we're expecting about 30-something people. We have about 20 in the room now. Now, if you each have around, let's say, 3 to 5 years experience, that's at least 3 times 20. 60 years of testing experience sitting in this room. Yeah. So what I also want you to do is not only to connect to the speakers like myself, but also create connections among you, because you can then, of course, exchange ideas. And I love exchange practical ideas because this is about networking. This is about actually really leveraging the knowledge that you have here in Malaysia. All right. So this is just one way for me of encouraging you to create this network. If you don't have it already. All right. So about the breaks hours, as mentioned, we're going to start now and continue till 1 o'clock, and we'll have 2 breaks. And the breaks, as mentioned, we'll just walk with the flow and see where it fits best in. Exercise already explained. We'll have a few combination of group exercises, exercises in your own and exercise together. And yeah, anything else? Any questions before we start? All clear. All right, great. Now remember, this is your time, your tutorial, you've registered for it. So please make time, make best use of your time. Yeah. So ask questions, make comments. If you don't understand anything, especially clarifications, do raise your hand. And we can clarify this along the way. You're also, of course, welcome to reach me afterwards. You have also my email contact at the beginning of your slides. You're welcome to drop me an email. I'd love to get, for example, if you go back to organizations and try going Agile and get some experience and you want to share some of your thoughts, some of your experiences, please do so. I'll be really appreciating those. And you might already have some experiences going Agile, good and bad. Please also feel free to share those today with your fellow testers in the room. All right, and be Agile. All right, so introduction. Now, I'm going to start. I assume that most of you might have an idea about what Agile is, and I'm going to give you start, so to speak, a bit different. All right. Have you ever heard about the famous artist called Van Gogh? He's a Dutch artist who made all these very beautiful paintings. Now, this is actually a famous painting by Van Gogh. It's called The Potato Eaters. You can see it actually in the museum in Holland. Now, some painters, you might think that most painters would just start painting. But actually, many of them, before doing some kind of masterpiece, they will plan for it. First of all, they will try to think of what I'm trying to conceive. What is my idea? How can I get that message across to the people who see that painting? And start thinking of how can I compose that? How can I make the composition of that drawing, that picture? What colors do I need? What kind of lighting? How many people do I need? What is the background? Perspective or not? Where do I place it in the landscape? Now, there are different approaches of those. Some will just do all the thinking in their head and just start drawing. Others will experiment, get fresh ideas, learn, try to learn it in a new one, and try multiple times. Now, Van Gogh, he was a big fan of experimenting. So he created what were called studies. This is a study where you first start, very simple. Before getting all the paint and everything in place, he will start just by drawing with the chalk or the pencil and create basically the first idea of the composition of the picture. You start looking at it. So, well, I need to maybe to change a bit. I will add the lighting source in the top. Yes. I will also, maybe this person shouldn't be here, should be over the other side. And maybe actually I will change a bit the order. I will also make this room a bit smaller. So he will then create another one. See, okay, here, I want to improve that a bit more. Actually, this person should actually be on this side than the other way around, yeah? Because I've changed my mind, yeah? Now, the thing is, what he's doing, he's learning, yeah? He's seeing the result of his work, he's learning, and he's applying those learnings into the next study. Now, by the way, which one do you think is the real painting that's in the museum today? Right or left? Left? Actually, it's this one. Well, Van Gogh, when he created this one, he thought it was too bright. I wanted to make it a bit more gloomy to get an atmosphere of depression, the atmosphere of a very kind of sad environment. So actually remove the light. So this is what you see today in the museum. Now, this is, of course, all the others are also famous, and some of them are even in studies of preliminary work is sold for millions of dollars. But this was the end result. Actually, there are more of those. So I think if you look at how many studies he have done, I think it was a range of 40 to 50 before we get into the real masterpiece. There's another famous artist called Edward Munch. I don't know if you know this. He made this. It's called Scream. This painting where someone is screaming. And actually, if you look now in the world, there are 4 paintings belonging in different museums of the exactly same motif, all done by Edward Munch, and all cost millions of dollars, of course. Now, my point is, this is in the field of art. Yeah? This is what we apply when doing Agile. This kind of resembles the concept, and I'll get back to basically the differences. All right. Now, if we take a step back, look at software development models. All of them, irrespective of what you're talking about, what kind of methodology, they're covering the same. They take you to the life cycle of a software from conception to implementation, delivery, use, and maintenance. Yeah? They describe that process. Now, common to all methodologies is that you have these activities. You have specification, where basically you initiate the whole thing, you describe your requirements. You might do the requirement description in different ways, but you still want to capture what is the intention behind the software. What is the idea? This is what the why. You want to capture the why you're doing it, and what you need. Why and what. This is important in the initial phases. Yeah. Then we have the design, high and low, and this captures how you're going to implement it. Then you have implementation, coding, construction, which actually you now have gather the requirements, you know what it's all about. You have an idea, you have the high-level design, the architectural plate, you start implementing it in the system. Hello, good morning. Yeah. Testing. This is where you come into the picture, most of you. Yeah. This is where you do the verification, validation, quality assurance. Now I'll explain the difference between those and how it will fit later on. This is where we want to make sure that 2 things. You want to ensure that, of course, that you have built your system right, and you have built the right system. These are 2 aspects, and these are 2 very different things. So one is actually checking against requirements, making sure that you're matching those requirements. Another thing is making sure that the requirements are fit for use, the right requirements. These are 2 very different aspects, verification and validation. Then, of course, you have maintenance at some point in time. After going live, you need to maintain that system. There'll be some changes coming in, and you want to keep it alive, making sure that it can accommodate those changes and test it again to make sure that basically it keeps evolving. Now, originally, back in the 1960s, when we started first describing software development models, processes, it originated from manufacturing. People in manufacturing, they have good experience from production. You have to manufacture cars, manufacture different electrical equipment, hardware. So they took the same concept and applied it to software. So what is common, of course, what they started with is so-called sequential development model. What does it mean? The activities you saw before, you run it in a sequence. Specify, design, construct, integrate, test, and so forth. Now, what you do is, before going from one step to another, you have a gate here. And the idea is that before going to the next phase, you make sure that the first phase is completed. Yeah. So here, you have for each phase entry criteria and exit criteria. And you can check whether you have met entry criteria, exit criteria. If you have not met entry criteria for design, you say, hey, I'm not ready to go to design. We have not completed this phase. If you are, you can go in. Once you have reached the end, you say, okay, now I'll check whether I've completed my exit criteria for that phase. If so, I can then take it forward to the construction phase. Now, the emphasis on this here is on planning, time schedule, deadlines, and budgets. Yeah? As you already know. And those obligations that I mentioned are typically associated with some kind of formal sign-offs. Now here, if you also look, typically you have handover from one team to the other. Here you have business analysts, for example, doing a specification. These will have the connection to the market, know what the users want. They can formulate the requirements and pass it on, specify those in a language that can be designed. So here in this phase, there's actually a translation of user needs, requirements, to technical requirements that can be implemented. Here typically you have architects working, high-level designers, code or lead developers who would be sitting and looking at the overall architecture, doing the high-level design. Once it's complete, you have the architecture in place. You have, so to speak, the pieces coming in. You have the developers starting implementing the different bits and pieces of the system. They have an integration phase. Typically, you have multiple teams here. And this is now where you can start putting together the different pieces and making sure it can integrate. Then you test the integrated system. After that, and depending on, of course, the use, you can train the users in training in the system features. You can deploy it in production, and then you can go into the maintenance phase. And as mentioned, it might be very different teams involved in all these aspects. Now, this is actually, I would say, the core of the sequential models. These are how they were born. They were coming from manufacturing, from production. I think all of you know this. Now, one important fact is that once finalized, requirements are frozen. So meaning actually, here, you have frozen the requirements. Yeah. So ideally, now you should not make any changes. In reality, you know that, of course, changes do happen along the way. So what they did, of course, in order to adapt, to adjust that model, is to create so-called a change advisory board, where you have basic changes coming in, and then you go through an approval process, and if changes are approved, then you can actually make the changes. So let's say, for example, you go into this phase, and you find out that something cannot be implemented because the requirement is wrong. You raise a change request. It goes back here for that specific piece of functionality, make a specification, design and construct, then continue. Now this process takes time. If you take maybe 20, 30 years back, this process might even take 2 to 3 years from the original specification of a system till the system is being released. All right. A variation of this is called the very famous V model. Okay, you know all this, I think. This one is very famous. A V model. Of course, the name comes from the shape, no surprise here. But basically the idea is to take the faces that we have here and depict it in a V model. And the idea is, of course, that this is also where the term waterfall comes in, because basically if you picture like water falling down here, you have this waterfall kind of, analogy. Now, the idea is, of course, that you will start up here, and then from requirement specification, go down to requirement, system specification, high-level design, low-level design, coding, and then, of course, you have all the testing activities. Now, the good thing about the visual presentation of this is that you have, on the right-hand side, so you have all the testing activities, and on the left-hand side, you have the specification and development activities. And for each, you can actually see that for corresponding, for example, user requirement specification, you have the corresponding test activity, which is the user acceptance testing. System requirement specification, you have the system testing. High-level design, integration testing. Now, for each and every phase of those, you have some objectives, which would be different. If we look at it from the left side, or on the right side, it could be testing activities. Unit testing is focusing on the individual pieces of code on the units, making sure that each unit works on its own. Okay? Integration testing is a combination of components or units. And the idea is to show test the interfaces that they are working together as an integrated or few integrated components. System is basically where you have to look at the entire system. Here, actually, you're also looking at the non-functional aspects. Right? Performance, security, usability, these things. And here, basically, you're accepting the initial requirement specification that you have started with. So here, actually, it requires some kind of involvement by end users. All right. So let me ask you. Have you experienced with this model already? How many of you are working in Agile today? Okay, a couple of you. Excellent. Now, let me ask you, what do you think are the main challenges with sequential and V models? What is missing?
Speed is missing.
Speed. As mentioned, sometimes this can take a very long time. So you have a speed aspect. This is one. Other aspects. Sorry?
Costly.
It's costly. Why do you think it's costly?
Because of every level we have to test. If you have the tester in the local tester inside tester, and maybe it is not the effective cost, but if we don't have the for inside tester, we have to invite another tester or the endpoint.
So do you think sequential models are more expensive than Agile? I think maybe the reason why you're thinking so, and I'll get back to that, is for something different. Maybe because of the changes. We'll get back to that. Any other points? What is missing here? What are the challenges with this? This looks nice and clear, yeah?
That is not so flexible in terms of change.
It's very rigid. Now, the point is, here, all sequential models are to a certain extent built on this assumption that once finalized, requirements are frozen. And this is where probably you think it's expensive, yeah? Because you don't have the flexibility for changes. Now, what is difficult, of course, here actually, and this is the main challenge in sequential model, you're asking your developers, your architects, your business analysts to think in advance of all possible requirements that the system should meet, both at the high level or low level. This can be very complicated, yeah? Because there are some interdependencies, some complexities. So here, basically, you're asked to look into the future and think of what will happen in the next 2 to 3 years, yeah? Which is very difficult. Which is often Why? It becomes costly because what happens is, of course, you learn along the way. You're all human beings, you're curious, you have the creativity. Once you get started, of course, this is where you think, okay, this is actually doesn't make sense. We need to do it a different way. But if you're frozen, if you're tied to that methodology, you don't have the ability to make those changes. All right. Now, a known fact, and this is actually a study that made by Bohm, Bim, and Basley. It has goes back to 2001, but there have been multiple revisions of that, and the numbers remain pretty much the same. This is looking at how much it costs to correct defects, fixing defects. So the idea is, here basically you have the requirements phase, design, coding, testing, and maintenance. Now if you look at, if you find, this is an average. So what they've done is analyze, I think, hundreds of projects, and based on the data from those, they generated this data. So they found out that basically, if you find a defect in the requirement phase, meaning before implementation, while still the ink is not dry, so to speak, if you find it before, of course, that has been implemented, it costs around $139 to fix, in average. Because, it's a bit, I think Carol gave the analogy, if you have a blueprint for a house, if you want to change, of course, the location of the door or the wall, while it's still on the blueprint, what you do, you just erase it, and move it to the right. Doesn't take a lot of effort, but it costs a lot of money. Now, if you do that after it has been built, moving that wall or that door can be rather expensive. Yeah? So this is why basically the cost goes up along the way. If you do it while it's being designed, it's slightly higher, because now you have already created architecture, you need to make some fundamental changes. Price will go up to $455. Doing coding is around $1,000 or so. In testing, now it starts going dramatically up, yeah? It's $7,136. Now this seems like rather high numbers. How come it's that big? But if you think about it, let's say you find a defect, you probably found similar defects in your life, where the system is very slow, for example, performance issues. And you find out, hey, actually our system seems that they're having issues coping with 10 users, and we're expecting 3,000 users. So this means potentially that you need to go all the way back and redesign the fundament. Redesign, basically, it's a bit like, you need to go back to the drawing board, so to speak, and make the changes. It's like you want to change the foundation of your house. Well, it's a lot of effort. So which is why it's not only fixing that particular bug, but it's also all the other associated effort. Now you have to think about also that it's not only the system itself, but also the user manual, also the release notes, also the new build. So there's a lot of activities that would add up to that cost. If you find it after being released in maintenance, this is the most expensive place. It will cost around $14,000 per bug. Interesting, isn't it? Now, yes?
Does the invention of the code generator or tools, automated tools right now, contributes towards reducing the cost of testing, or cost of corrected the defect?
Well, it will not help you correct the defects, because automation tool for testing will only help you accelerate.
For testing, automated tools for development,
Yes.
code generator, something like that.
Yes. Obviously, some tools will make a bit cheaper, but the trend is still the same. So maybe now with the use of the tools, it's not 14,000, maybe it's 10. But the trend is still the same, that for each phase, price go up. And this of course, you're gonna change this, because the worst thing is, you have a user, calling you, I found a bug in your system, and you need to send a patch to fix, basically, to correct that defect. And you can send if it's out in the field, nowadays you're lucky maybe that you have a system that's connected, so you can just send a patch online and people can get it from there and they update the systems. In the old days, it even used to be more expensive because it meant that actually you need actually to recall products, to recall equipment, to recall basically software, make a new product and give it to the customer. I used to work myself in the medical devices area, and it meant, worst case, we're selling ultrasound scanners. It meant that we need to send a technician out to each and every hospital where we have equipment to make fixes. So, which is why, again, projects go up along the way. Now, what is also interesting, another study, this is coming from the NIST report. Again, there have been several iterations of those, is that you look at where do we find the bugs, typically. And where do we introduce them? Now, there are several studies showing that where are the majority of the bugs introduced. They found out that most of them are actually in the requirement phase. About 68% or so, or 70% are coming from the requirement and design phase. These are either wrong requirements, missing requirements, contradicting requirements, and so forth. Sometimes missing requirements is a big issue. So it's a bit like when you go on a trip and you're on holiday and someone says a question, did we forget anything? It's difficult to answer the question, yeah, because you only know after you've gone to the trip, yeah. So missing requirements is often a big thing, and you will not miss it in testing, because if you're testing against the requirement and the requirement is not there, how can you verify that it's not there? Yeah? So 70% come from requirement phase. About 20% or so, a bit less, is coming doing coding and unit testing. User acceptance testing, this is typically where you make changes. Okay. And jokes on metrics. Okay? Only jokes are on metrics. Now, I have this bunch of people who will meet every weekend to tell jokes, actually. So it's a joke on jokes, yeah? So each week, they'll sit together over some food and drinking and say, okay, how about this joke about this guy who wants to work, and keeps a joke, and everyone starts laughing, yeah? And that keeps in turn telling jokes. Yeah? Until one day, one guy says, I have an idea. Instead of repeating the entire joke, we just give them all numbers. Yeah? So number one would be the joke about the guys who travels abroad, number two would be the guys who eat the durian, and number three would be the, and so forth. Yeah? So instead of saying the entire joke, they can just save time and say, how about joke number three? And people start, oh yeah, this is a good one. Yeah? So start gathering, start listening, let's do this. And they, after a few weeks, they meet and say, hey, how about joke 14? And people start laughing. They say, hey, I know one, joke 37. And people start, ha, 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 this is a very good one. Yeah? And then one says, how about 247? And people start laughing, but one guy, he starts rolling on the floor laughing, and really, this is the best joke ever. And he says, hey, what's happened? He says, it's the first time I hear it. All right, it's a better. Right. So thanks you for laughing politely. One of my friends was actually, he was giving a speech in Japan. Okay? Now in Japan, there was a lot of simultaneous translation to what he was saying. So he was speaking in English on stage, and then there was some guy who was a translator who was translating the speech to Japanese, and people were just wearing, of course, the hearing aids, and they could see, or the headphones, and they can hear it in Japanese. Now this guy goes on stage, and he's an American guy, so he goes on stage, and he wants to start by telling a joke. Yeah? Now he comes on stage, and he starts saying, well, let me start by telling a joke. Now the translator says, This guy is an American speaker, and it's very common in the US that we start by telling a joke. So please, of course, make sure that, of course, that you can accommodate, of course, the, this request of the speaker, and then, of course, the speaker starts translating a joke. Now the translator says, well, now he's about halfway through the joke. I don't know what it's about, but we're about halfway through. We're almost getting to the end. And I'll give you a sign, and now you can laugh. And people started laughing. Yeah? And he was standing on stage. Wow, my joke went very well. All right. Okay, enough about jokes. All right. This session is on metrics, and I think the first slide you've probably seen. Yeah, I'm gonna just, for the sake of being on the same page, I think most of you have seen this yesterday. Yes? This is my testing process. And I was asking the question, of course. We have software version coming into testing. We do a lot of stuff here. Add time, effort, money. What comes out? The software in the same version. Testing itself does not change the software. We agree? You're not hacking the binaries and changing executables. You're not doing that. So the only thing that is coming out is information. And the theme of the conference, as we're discussing, is testing as a service. And as mentioned, our main function as testers is to be service provider, and a commodity that we're selling is information. Now, if we're doing a good job, as mentioned, we're providing good, solid information. Ideally, substantiated by numbers, by data. Because obviously, if we want someone to subscribe to that information, want to be relevant, we want to be accurate, want to make sure that what we're passing on, we're giving them a good basis for making a decision. This is where numbers come into the picture. So this session is on how to improve the basis for the information that we're providing to the stakeholders to make a decision. All right. In other words, what we're doing is all about information. Let me start with the first quiz here. Anyone knows what this is? How do you guess? It's a graph, yeah. What does it show it? Yeah, excellent. This is taken from a football tournament for one team. They have to take it from a European team for actually Manchester United. Yeah. Now, look at this. What can you see here on this graph? Anyone?
Points. Game.
These are the points, yeah? What does the green and red shows? Whether they won, draw, lost. That's correct. Now, as you can see, this is how they've been progressing. So there's a red line down here. This is the threshold. If you're below this line at the end of the tournament, it means actually you're going down one division. Yeah. So this is not the right place to be. And if you want to qualify for Champions League, for example, you need to be in the upper quadrant. Yeah. Now, another thing you can see is this graph. Anyone can say what this is?
Goes off. For goes.
What are you saying? Yes, goals, exactly. So what is this?
How many goals they scored?
No,
Oh, that one. That. Meaning, you're talking about the 1, 5, 10. Oh.
This is the time. So this is the match. You start from first minute to 90 minute. Yeah. And as you can see here, this is in the league, in the cup, in Europe. So this is how many goals the team has scored. This is how many has been scored against them. Yeah. So by looking at this, when do you think Manchester United is most dangerous?
End of the end.
There are a few areas. Yeah. They're very dangerous here. You can see they have scored, multiple goals here, here, and here, 8, 8, and 6. So the last part of the first half, they're very dangerous. It's also very dangerous here in the beginning, actually, first about 10 minutes. And here. So, and where are the weakest? They seem to be weak also here and here. Yeah. Actually, this is overtime, what you see here. So here, actually, at the very end of the match, they seem to be very vulnerable. So if I'm a trainer, and I see this is my team, if I want to improve, what should I do? And say, here, here, and here, I need to improve the defense because this is another area where basically we are very vulnerable. Maybe this is here where we're tired, where we are letting in goals, we're making two chances, making two high chances, and so forth. And I can also see that here, it seems that after the break, because you have typically a break after 45 minutes, it seems that it takes a lot of time before the team comes up to speed. So maybe I need to train the team to improve the skills here. Now, my point is, this is coming from football. All this information is within these two charts. Now, if I want to communicate my message, this is very easy. Yeah? This tells my entire story. Now, what I want to do today is to give you some thinking about how you can create something similar for testing. How can you capture the information that is relevant for you, for your team, for the stakeholders, and how can you communicate that back to the organization? All right? Now, just for information, there are a lot of slides in my material, and some of them are there for the theory. Some of them I will not go into the depth of. So I will focus more, because it's also an afternoon session, we'll focus more on discussion and practical exercises, okay? So some of them I will not cover I will only cover superficially. However, if you have some questions, of course, feel free to ask, and I can clarify those. Now, what I'm basically will cover today is first starting with the measurement fundamentals. This is getting the basics in place, the essentials in place. How to use metrics to assess the state and quality of the system being tested. One important question: when to stop testing? When have you done enough testing? When do you think a system is ready to be released? And discussions about that. Ideas about how to establish your testing dashboard. Ideally, what I want to have is something like this, as mentioned, for testing. That would be like the dashboard that I have in my car, that is showing me how fast I'm going, if I've forgotten my seat still on, how much gas there in the tank, and so forth. That's for testing. Looking at metrics that can help you improve the process. At the end, of course, and this is all throughout the entire session, examples and discussions. And I'm actually showing you today one example taken from a real project. So I'll take you some metrics that have been used in a project, and we can have discussions around that. All right. So basically, this is about the training. Myself, I'm not doing another introduction. I've been here for a few days, so most of you have heard about myself and background. Participating with you, so hopefully, basically, that you can interact with me this afternoon. I'm still missing a few people. I think they'll probably show up along the way, but we will just start. Hours will continue around till 6 o'clock. Maybe we'll finish a bit before. And there will be a break around 3:30, 3:45, depending on how it goes with the exercises and the slides and the discussions. Logistics, there'll be some coffee and cake and tea in the break around, as mentioned, in the time period between 3:30 to 4:30. And again, as I also said in my other sessions, this is your tutorial. Please sure to interact, make comments, ask questions, participate, express your opinions, your second opinions. You can disagree with myself. If you want to disagree, you can share examples and be agile on that, in the sense that don't necessarily need to follow the structure that we have. If you want to ask questions in other areas as well, feel free to do that as well, meaning related to metrics. All right, so let's look at some of the fundamentals. First of all, What do you need to measure? And I think with the football exercise, we'll probably address some of those. But let me ask you, ma'am, what do you want to measure? What is your objective for measurement?
Based on the measurement, we know where we are.
Okay, you want to assess, you identify where you are based on the measurement. Other views? I'm picking randomly. You can ignore me or you can choose
I want
to.
say the same thing.
Okay. Other views? Yeah.
We need to know the quality of the system of tests.
Okay, you want to assess the quality of the system on the test. Other views?
Performance.
Performance. So you want to assess one quality attribute of the system, which is performance. Excellent. Other views? Bugs. You want to control the bugs. You want to count the bugs and identify how many are open, how many are closed, have been identified. Excellent. Other views? Yes, sir.
Establishing a baseline.
Establishing a baseline. Excellent. So typically, it falls into those 5 categories. Yeah? Understanding, gaining insight into where you are, identifying relationships, and again establish baseline and goal for future assessment. Typically, using metrics, as in the example with the football match, you can know where you are, as mentioned before. This is, for example, shows you where you are now. You can use this to improve. So you have now a baseline, and you can then improve your actions. A few months later, you can do another assessment. You can collect the data, and they can compare where you are compared to the baseline. And you can see if there's you have moved compared to your baseline, or if you moved in the right direction. Because if you moved in the wrong direction, you might have applied the wrong measures. Also use metrics to assess. Both assess the quality of the application as discussed, assess where you are compared to the plan. Are you making progress? How many of the plan tests? If the future looks like the past, then this is how it's going to look. I'm going to extrapolate based on what I know today. Yeah. That was improve. Identify root causes for the issues so we'll be able to remove them. Last but not least, communicate. Metrics are very good at depicting graphically, as you showed before with the football example. It can help you share the knowledge across in the team. Now, if you take a step back and look at measurements in general, obviously in science, measurement and data are essential. Typically start by using data measurement to establish some observations. We take those observations, we make a generalization, and then we pose a theory. And we can then use the data measurement either to confirm that theory or to refute that theory. So using measurement and data, it has been an integral part of science in general. Statistics. So let's start with the definition. Measurement is the process by which numbers or symbols are assigned to attributes of entities in the real world in such a way to describe them according to a clearly defined rule. Okay? Or clearly defined rules. Now, what does it mean? It means that, first of all, we have attributes. These are characteristics. These are parts of, for example, your system, either physical or logical, that you want to put a number on, assign a number to. That enable you to describe them according to a clearly defined rule. So, obviously, you all need to agree on that rule. If you don't agree, it becomes difficult to measure. Yeah? Now, we all know, for example, what the defect is, what the bug is. Yeah? Sometimes we can disagree, for example, about the severity of the bug. You know, someone says it's high, someone says it's low, and you have, of course, a debate. What you want to avoid, of course, is to have the fluffiness in your rules that will allow someone to basically dispute whether the number is right, whether the metric is right. So you want to have an agreement on these rules. show you some examples of that. Now, if you are, for example, taking an ISTQB, then you know that metrics and data measurement is a part of the control mechanism. So if you have the normal generic process of planning, analysis and design, implementation, execution, then you have evaluation, activity, and reporting and test closure, you know that in parallel you have the control part. And here, you use metrics to control the process. For example, in the planning, you might agree on certain threshold on, for example, when we have finished testing. Let's say, for example, in the planning here, and this can be at any phase. Let's say, in the planning you can say, okay, before getting out of testing, I should have 0 severity 1 defects. That can be a rule, for example. Yeah? And if you come here at the end of the implementation execution and you find that you have 1 defect or 2 defects, then you're clearly not meeting that threshold that you have defined. Then actually you're allowed to send it back. It's not done yet. Or you can agree with the control set, hey, we're going to allow it anyway. Yeah, management is approving, so just send it. Anyway, it's going to proceed to closure. Well, we're just going to describe it in a release note. So, the point is, metrics is an integral part of that process. All right. In a control process. According to ISTQB, in order to control testing, it should be monitored throughout the project. This is coming from ISTQB. In order to monitor something, you need to have the data. Otherwise, how can you monitor it? Yeah? So, what kind of things you can monitor? You can measure and analyze results. It can be the results of execution, can be the results of the planning. You can compare actual progress against the plan. This is where you, for example, if you need, for example, to add resources, if you're ahead of schedule, behind schedule, you can detect whether you need to have some corrective actions to bring you back on time if you have deviations. You have status reports showing the progress, coverage, how much code coverage have we achieved, how many requirements have we covered, how many screens, how many user stories, depending on the unit of measure. Which I was talking before, you need to agree on what kind of thing you're measuring. Now, again, in order for the metric to be, as mentioned, we are information providers. In order for us to provide good information, we need to have metrics that will be smart. What do I mean by smart? Specific, measurable, acceptable, relevant, and timely. It's an easy way of remembering smart. Specific, in the sense, addressing exactly what they should address. Measurable, makes sense. I mean, it's a metric, so if not measurable, of course, it doesn't make sense. But some things are more measurable than others. What do I mean by that? Sometimes it's easy to measure because you can just count, for example, bugs. Yeah, you look at the bug reporting system, have 5 bugs. Other times, might be more difficult to measure because sometimes maybe you need to do some subjective evaluation. You need to ask some expert. I'll go to you and say, what do you think about the software on a scale from 1 to 10? You say, I'll give it 6. All right. That will be subjective, yeah? So, measurability can vary depending on the metric. Acceptable, meaning you agree, have a consensus around what is this metric, what are the rules, what are the thresholds that we agree on. For example, we agree that all unit tests should have a coverage of minimum 70%. Just an example. If we don't meet that, then clearly we are not meeting, for example, the exit criteria from a particular unit testing phase. If we are, we have met the criteria, we can move on. Just an example. Relevant. I've seen some examples of people who get excited, come to a training course like this one, and then they started measuring everything that can be measured, and sometimes can be information overload. Yeah, you go there and you have measuring this and this and that. But at the end of the day, how many of them are really relevant for you and your team? Maybe only a handful, maybe 10. So please bear in mind that don't get overexcited with all the metrics. Keep it to the level that is needed. Now today I'm going to show you loads of metrics. Yeah? Not all of them will be applicable in your context. Please decide wisely on which metrics are useful for you. Yeah? And last, timely. I need the right data at the right time. Some information, some data is easy to get. For example, just go into the bug report and collect the data from there. Everyone can create a report, so easy to get it. In other occasions, it might be more difficult. Maybe I remember, for example, from my past career, that I needed some data regarding how many hours have been spent during testing. And the only way I can get this data was to send an email to this guy who has the access to the system where people are reporting their hours, and he would send me an email back. So this for example, it has some dependencies, more difficult to collect than just going into the bug reporting system. Yeah. One thing for sure is, want to have data at the right time. Now, it's a bit like, I assume you all get newspapers or subscribe to some kind of electronic media, yeah? Let me ask you, what is typically the value of yesterday's news? Very limited, yeah? Maybe sometimes you want to go there for historical purpose just to see what happened, yeah? But otherwise, do you read a magazine or an old newspaper? Typically you will not do that, yeah? Why? Because basically it has probably been updated since. A lot of things have happened that has changed. So make sure that you can, when you discuss metrics, identify what information sources do you have and how often do you get the information. Sometimes it might not be that easy. Now, there are several ways of starting the process of introducing a metrics program position. If you don't have any, you can, of course, one way would be taking some best practices, maybe looking what others are doing, listening to experts, and adapting those. You might also want to create something from scratch, identify what are your needs, and developing the metrics set of metrics that will suit your needs. Now, one approach for doing this is called GQM, which stands for Goal, Question, Metric. The idea is you start by defining the goals, and here you should not have too many. You should have at least, obviously not more than 2 to 3 goals, that's it. Then start asking questions that must be answered in order to know if you're reaching that goal, and then establish metrics to support that question. This is very abstract, yeah? Let's make an example. Let's take an example. Let's say my goal is to determine whether I'm ready to release the software. This is my question. So this is my goal. Right? What kind of questions can you ask in order to know whether you're reaching that goal? Anyone? Let me ask you. Let's say now you're management, all right? I'm a test manager, and you want to ask me whether I've done my work, whether I've finished testing, ready to release. What kind of questions will you be asking? I know it's difficult after lunch and everything. What pops up to your mind?
Is testing complete?
Is testing complete? That's a good question. All right. Other questions? Sorry?
How many defects?
How many defects? Make more into that. How many are open? Yes, still open. All right. Other questions?
How long it takes to get ready for defects?
Ah, so now you also want, for the open defects, you want to know how long will it take to fix. Excellent. Other questions?
How long are your comments
all the requirements covered. Excellent. So my point is, now you're asking these questions, yeah? You've asked one about, are all requirements covered? So if you take that question, you can break it down to a metric. Coverage. That will be one metric. And here the question is, what type of coverage? You said requirements, right? So I can establish a measure to count requirements that have been completed. So I need two items. I need requirements and have completion against each requirement. Yeah. You mentioned about open defects. Yeah. So the question was, how many of the open defects? What is the effort needed to complete the? What is the completion effort needed for the remaining open defects? Yeah. So you need two metrics for that: defects and effort. Yeah. And you have other questions you had on completion. How many of the tests have been completed? Asked, yeah. So the question was, how much is completed? The metrics would be test cases, number of test cases, and status, open, closed. Yeah. This is my point. This is how you can easily get from high-level objective down to the concrete metrics. By the way, this is a good exercise to do on a piece of paper here in an afternoon. It doesn't take a lot of time, but sometimes it can also help you identify which metrics are relevant, yeah, because you have loads of metrics. But if there are some metrics that are not mapping up to the goals, then maybe you don't need them. You get rid of it. All right. Are you with me?
Yes.
All right, excellent. Excellent. Let's start applying the metrics into action. By the way, there's an article on this. That I can share with you if you're interested in that. It's called What's on Your Dashboard. And I've written that some years back, I think it was 2007. It's still relevant though, even though it's 10 years back, but I think it described the method with some concrete examples. If you're interested in that, just drop an email on the, I'll send you the article. But basically, you see this is an example that we just mentioned. The goal was to determine the release readiness. Right? It's broken down to what are the quality requirements, what is the current quality, what is the risk of releasing, what is the timeline. And those again, broken down to metrics. All right.